Good morning. Um, Welcome to today's webcast. Um, I'm William, Application Engineers of ATE. So today's title is Why Do You Need Simulations Advanced Packages? So this will roughly take about 30 minutes to 1 hour. Below is my email. If you have any questions, you can always drop me an email later on after the webcast. So uh, So today's agendas will be on a few points. So the first one, I will do a quick introductions of what finite elements analysis is all about. If you have been following my previous webcast, you would have know about this already. So then why do you need simulations and one packages? And I will utilize SOLIDWORKS simulations as platforms to explain to you in details of what are the advanced packages and what are the advanced functionalities of FEA that will be helpful in your daily tasks. And then I will summarize everything and end the webcast later. So, a quick introductions. What is FEA? So I categorize it into four boxes. Started off with the most basics and the most easy to understand is the linear statics. And then we have non-linear statics due to the certain characteristics of the materials or the behavior of the structures. Then we have linear dynamics where we start considering huge movements or dampings or inertias into the picture. Non-linear dynamics where we cater for non-linear materials. So a quick graph here will show you that for force and displacement graph. So you will see that linear static analysis will be they will have a proportional relationship, and non-linear analysis is whatever goes beyond that particular proportional graph. Then we will have material non-linearity components such as the rubber, plastics, which has a very short life of linear characteristics. We all consider that as the material non-linearities. And additionally, we also have force non-linearities, meaning that the force are changing over a period of time. It can be changed it can be assigned a force in the x direction, and eventually there is a secondary force on the y directions and tertiary force in the z directions later on during the period of testing. Then another non-linearities of simulations, we will consider that as the structures non-linearities, where the load changes as the structure changes, deform in structures. Then where it comes to dynamics analysis, then we will start considering inertia, and we will also consider the dampings in the models or in the structures due to the material properties or due to the structural properties itself. So this is a quick understanding of what are FEAs all about. And to let you understand in depth, we utilize SolidWorks simulations packages to explain more in details of what are the packages available and which fits your daily task well. And a disclaimer here that I did not own all the contents by myself. I grabbed it from somewhere, but I will use it as a guide to go through the whole webcast. So in simulations packages or in analysis packages of SolidWorks, we have SolidWorks simulations, we have SolidWorks flow simulations, and we also have plastics. And today our focus will be only on the FEA portions of things, which is the simulations packages, the simulation standard packages, professional packages, and premium packages. So to link it back to the previous graph that I mentioned earlier, linear statics, non-linear statics, linear dynamics, and non-linear dynamics. So linear statics are whatever covers only in these particular columns. which is the stress analysis. Okay, so whatever falls under the nonlinear and dynamics will fall under these particular premium packages, and for whatever covers under professionals will be more like a additional tools to calculate for a specific or industry specific testing. So to understand more, I will go in depth into one by one to go through what are each of these testing, each of these analysis indicates, and what are each of these analysis are about. So first of foremost, let us go to the linear static portions of things, which is the stress analysis. So when we talk about stress analysis, we will be analyzing on a few things. We can analyze on sheet metal sheet. We can analyze on weldment structures, steel structures. We can analyze on one particular part, or we can even analyze on the whole assemblies. So for static analysis, we were able to do for parts and assembly. Okay, so as I mentioned earlier, we were able to do for solid meshes, shell meshes, which is typically sheet metal component, beam meshes, which is typically weldment components, or components such as I-beam, hollow bars, cylindrical bar, and so forth. Then we can also assign context such as weldings on the connecting components. So also the connectors can be automatically assigned as well. So examples of how does the results or the post-processing looks like are somewhere in this picture. Okay, this particular video, animations video. And then if you see here, these are what we call as elements. So what happened here is that we discrete all the components into small elements, and we analyze on each of these particular components. So this is basically on static analysis, on stress analysis on parts and assemblies, together with all the connectors such as welding and the bolts, pins, and springs if required. So under the simulation standard packages, we also have a motions analysis. So motion analysis, the motion analysis here consists of time-based motion. So what does time-based motions mean? So time-based motions is basically we assigning all the context and we assigning all the conditions, and let the force do its jobs, such as gravity force or motor force, to do all that. So it helps you to specs for the cylinders, the pneumatic cylinders, or the specs for the motors required in your studies or automations. And then it will also test on mechanisms, whether there are any interference during the movement, and what are the specifications, or what are the graph forms that you can get, what are the force value that you can get when you assign a certain value of motor. And then we can also consider the dynamics and static frictions in the component surfaces, okay, for better presentations of your products. And examples, it will be on the left hand side, which is the chain. So this chain is where the pins are being pulled out, and during the interactions, it consists of the frictions between the components, and then it also consists of the component damping itself. So these are what you are expecting in the time-based motions analysis. So moving forwards, under the standard packages, there are a fatigue analysis as well. So fatigue analysis basically, in other terms, will be cyclic load or cyclic test, which is repetitive loads on one component, and we calculate for the lifespans, or we calculate for the factor of safety, we calculate for the life and the damage on the components after dedicated or specific amounts of cycles. So this is a total point. So if you look at it, so we can calculate for the design, the product design, the lifespans of the products. So we can always put in the the cyclic loads, the cyclic cycles, and calculate from the analysis itself. So then heading back, we will move forwards to a higher packages, which is the simulations professionals packages. So this is a combinations of linear and a little bit of non-linear, but not actually a full range of non-linear capabilities. So when I mean a little bit of non-linear analysis are such as frequencies, buckling analysis. So those drop tests, those are considered as slightly on the non-linear portions of analysis. So we will go through one by one as well for the professional packages. So let's look at the optimized capabilities first. So what happened here is that the optimized capabilities is actually the parameter. We calculate the optimizations based on parametrics. In short, we call it as a parametrics optimizations, which is control based on the specific values of thickness, radius, linear dimensions, and so on. So if you look at it, the aim is to reduce weight by controlling dimensions and maintaining the maximum stress levels at the range that it can be accepted. And then it can also be combined with the frequencies analysis, and usually is used in the later stage of the development process. And below are a quick interface of how does parametrics optimizations works in SolidWorks. So basically, we assign goals and we assign the load factors or dimensions that we would like to change or varies across the time. And then the simulations, optimizations, parameter optimizations will automatically calculate for the optimal design and highlight it in green. So that will be on optimizations. And moving forward, let's look into event-based motions. So event-based motions are different from the time-based motions that we have mentioned earlier in the simulation standard packages. So let's look into event-based motions. So how does event-based motions does is that event-based motions are analyzed based on event, based on the events or the next actions are triggered by the previous event. Whereas in the time-based motions, what we need to do is that we are the one that assigning the time, we are the one that assigning the displacement or the movement of the components in a specific durations of time. Whereas in event-based motions, we can utilize the sensor, we can utilize triggering functionalities to calculate for event-based analysis. So in short, it is a simulations of a sequence. There is a capability to use sensor, and quick examples will be the one on the right hand side, where the sensors told to sort the yellow colors and red colors cubes into different tray. Okay, so heading back, then we will look at pressure vessels. So the pressure vessels analysis here are not very robust in terms of for people who calculating for low pressure tanks. So we are focusing more on the high pressure tanks, where it requires a very in-depth analysis on the flanges or on the combinations of loads, such as the displacement loads, stress loads, pressure loads, and everything. So In short, pressure vessel analysis is a design studies that combines the effects of multiple loading scenario. So, and it comes with stress linearizations, which is something important for you to calculate or to abide by the ASME code, where the membrane stress and the flange stress are important. So, combination of loads, as I mentioned earlier, for to calculate for high pressure tanks. So heading back, we will have further capabilities in the simulations professionals, which is the frequency test, and it is highly related to buckling. So after frequency test, I will be moving forwards to buckling straight away. Rather, I will skip the drop test for a moment, and then I will come back to that later. So frequency tests are typically important when we are calculating on moving components or components which is attached to one particular motor, or in a seismic earthquake scenarios. So frequencies can be very fatalities. It can be very fatal when the natural frequencies or the resonance are being met. So we can calculate for a different modes, different mode shapes, and plan to how to avoid these particular vibrations by adding ribs such as in the bottoms. And the ultimate goal is to avoid any vibrations that will cause a huge damage to the components or the structures. So if we are calculating for frequencies only, it might not be enough. Hence, there is a buckling analysis for components such as thin tall structures, like a crane or a long shaft. So instead of frequency analysis, a buckling analysis will be an additional analysis that you need to go through. So buckling is a phenomenon where components damage or components fail instantly after a specific loads or after a specific deformation shapes. So bucklings are not easy to be calculated, or are not easy to be predicted from static analysis or linear analysis itself. Hence, it will come into handy when you want to calculate for thin tall structures such as a table components, crane components, or long and thin shaft. So, an examples will be under these particular animations that shows the bucklings modes of the structures, and the indicators will show you that whether it will buck when you are assigned with a certain load or not. So going back, as I mentioned earlier, I will move back to the drop test. So drop test is a quick study, or in fact, I will call it as a first pass of nonlinear analysis when it comes to impact test. So this drop test, you are able to indicate the value of a dropping height, or indicates an initial velocities value for you to run, for you to calculate the drop test. So basically, it's a stress analysis of impact. So bear in mind that impact loads are considered as nonlinear loads or dynamic loads, as it is not applied slowly to the components. Then it can cater for the contact in the assemblies, and we can put in the drop distance, and we can put in the velocities value as well. Okay, examples will be on the this. So simple calculations, animations, and we can capture every single moment after the impact. Then additionally, we have thermal analysis as well. The thermal analysis in these in the simulations packages are very highly related to conduction analysis. Also, although you have the capabilities to put in a conduction value or the radiation values on the surface of a component, but we won't be able to capture the temperatures of the fluids. So it is only capturing the informations of a component, and it calculates for steady state heats. So additionally, here is that after you have calculated the thermal analysis, after you calculated the thermal value or the temperatures at the end of the steady states, the data can be transferred back into static analysis or any nonlinear analysis for further residual stress calculations or thermal expansions calculations that causes warpings and that causes warpings phenomena or scenarios. So this is where the thermal analysis comes in, especially useful in the semiconductor industries, where a warpage is one of the factors of failures in the analysis. So going back, we head to the last ones under the simulations professional packages, which is the 2D meshes. So for components such as symmetrical components or cylindrical components, it's always good to use a 2D meshes capabilities. So these are nothing related to any analysis. This is just a advantage, added tools to help to get your calculations faster. So when I mean faster, it means really fast. Sometimes it can go up to 10-folds of the analysis, where we only calculate for one sections of the components. And if you need to present this analysis to your customers for better understanding, then we can also see the results in the full 3D modes rather than only sections of it. So we can provide you the capabilities. So this is just a productivity tools to get the analysis fast, the calculations done faster, and to get the first pass results quickly without needing you to fix too many of the to schedule too much of your time in the pre-processing process. So we have done for the simulation standard and professional packages, which purely on the linear static analysis, and a mixtures of a little bit on the nonlinear and on the dynamic analysis. Then moving forwards, we have the simulation premium packages, which is the highest packages among the SolidWorks simulation suites of products. So as I mentioned earlier, under this graph, the whatever under the nonlinear static portions, the linear dynamic portions, and the nonlinear dynamic portions are all fall under simulations premium packages. So to understand more, let us go into the first one, which is dynamic analysis. We call it's a linear dynamic analysis, let's say. So linear dynamic analysis is we cater for the different loading conditions, and we also cater for the damping and inertias of the components. So typical examples will be the earthquake, and under the transient analysis, we can always put in time dependence load by inserting as the result as a load in the graph forms or in the data set forms, and then the results, the transient results on the that capture on the times can be captured, and it will pretty much indicate the actual case scenarios. So we can also put in and do an harmonics analysis. Typical examples would be the shaker table or random vibrations, which is the earthquake vibrations. So this is like some examples of the analysis which is related to linear dynamics analysis. Okay, so moving back, then we will look into nonlinear portions of things. So nonlinear portions that I mentioned earlier. So nonlinears, we look into three types of nonlinearity. That if either one of these scenarios being hit, it being fulfilled, it will be a nonlinear analysis. So the first one will be material non-linearities, which is materials such as rubber, plastics. We consider that as non-linear material, where they have a very short cycles or very short linear characteristics. So the next non-linear is the loading non-linear, means that the load changes over time. For example, the first seconds is in x directions, the second seconds is in y directions. So that we consider as non-linear loads. Then the third portions of non-linearities is the structural non-linearities. So as you see, you will notice that for certain components such as a rubber ruler or a plastic rulers, when you load it on one point, when it reaches a certain point, you will notice that the load has changed in the directions that we consider as the non-linearities in the structural deformations. So some examples here are the rubber seal and permanent deformations we'll consider as a non-linear analysis as well. So the animations below are some examples of the analysis that can be done in a non-linear analysis. So moving back, we will look at additional functionalities of simulations premium, which is the composite analysis. So the composites here are not calculating based on structures, but it calculating based on the number of plies and the plies arrangement and orientations in the composites material. So taking these I-beam as an examples, or I structures as examples. So it consists of 8 plies, and then each of the plies come with a certain thickness, with a certain orientations of a degree. And of course, it can be assigned with different materials across different plies as well. So composite layers, orientation of layers, and yeah, it can also cater for the sandwich structures such as honeycombs and plywoods, for example, is one of the kinds of composite examples. Then yes, it enables to calculate for certain things in the composite packages. So, and examples, a typical case can be an FRP tanks, a fiber reinforcement plastic tank. So that will be the best place for you to calculate to use composites to calculate for the FRP tanks durabilities and stress. So that will conclude on the simulations suites of packages under the standard, professional, and premium packages, which cover from the linear analysis to non-linear analysis, linear static, linear dynamics, non-linear static, and non-linear dynamics calculations. So analysis on the fluids dynamics, computation fluids dynamics will be fall under the flow simulations packages. Calculations of a flow in a plastic mold will be fall under the plastics packages. And I will leave that to another day. So if you have any questions, feel free to email me. So you can send me any inquiries if you have any questions, or you are not sure whether the current task or current products that you are doing now require what kind of testing or what kind of analysis. Yeah, no worries. You can always email me and I will be able to answer your inquiries. So our marketing will be sending you the survey forms in a short while, and yeah, please feedbacks on the contents, and please feedbacks on the webcast, and so that we can improve in the future. So with that, I will end the webcast. So thanks for the attendees, and see you. Have a good day.